So guys, today we are going to discuss nodal analysis. So this is the circuit. We are going to find V1 and V2. So first we need to convert these voltage sources to current sources for simplicity. So we can easily solve the circuit. So if we are going to convert voltage sources to current sources, we are going to apply Ohm law. So according to Ohm law, I is equal to V by R. So here for this V is 1 volt and R is 10, so which is equal to 0.1 ampere. So this is IB, and for IA, which is this one, so the voltage given is 8 ohm divided by 2, which is equal to 4 ampere. So IA and IB are found. So now we found that IA is equal to 4 ampere, IB is equal to 0.1 ampere. Now we are going to apply nodal analysis. So here we got two nodes, V1 and V2. Let's solve node V1. So for example, this is a node V1. So current entering to a node is I. The current leaving that node is I1, I2 and I3. So we define that I1 is entering to a node, and I2, 3 and 1 is leaving that node. So according to Kirchhoff current law, I plus minus I1 minus I2 minus I3 is equal to 0. Now I1 plus I2 plus I3 is equal to 4 ampere. So I1 is actually equal to V1 divided by 2 ohm resistance. I2 is actually equal to V1 divided by 4 ohm resistance, and for I3 here V1 minus V2 divided by 6 ohm resistance, and which is equal to 4 ampere current. Now let's simplify this equation. Let's simplify this equation. V1 divided by 2, V1 divided by 4, V1 divided by 6 minus V2 divided by 6, which is equal to 4 ampere. So the V1 here common among the following, and we take out V1 as a common. Now if we add all these three things, so it will equal to 11 divided by 12, and V2 is a V2 divided by 6, which is 4. If we multiply this whole with 12, so let's multiply this whole with 12. So our final equation will look like this: 11v1 minus 2v2 is equal to 4, 8. So this is equation for node v1. So for node v2, as we know that there is a 4 current associated with this node v2. So IB current is actually leaving a node, and we assume or we define that the remaining current is also leaving that node. So let's put the equation for this. So we have minus IB minus I3 minus I4 minus I5 is actually equal to 0. So if we simplify the equation, so put all the value in this equation. I3 is actually across this branch, so which is V2 minus V1 divided by 6 ohm. I4 is across this branch, which is V2 divided by 3 ohm. I5 is across 10 ohm resistance minus 0.1 ampere. If we simplify this equation, V2 divided by 6 minus V1 divided by 6 plus V2 divided by 3 plus V2 divided by 10 is equal to minus 1 ampere. So here V2 is common among 1 over 6 plus 1 over 3 plus 1 over 10 minus V1 divided by 6 is equal to 0.1 ampere current. So if we simplify this equation, so it will become, so this is V1 1 over 6, this one, and this whole statement is actually equal to this whole term minus 0.1. If we multiply this term by 30, so our equation will look like this: 5v1 plus 18v2 is actually equal to minus 3 if we multiply this with the 30. So this is equation for node V2. So let's write these both equation. So equation for node V1 is equal to this and equation for node V2 now it's for node V1, this is for node V2. So the matrix form for this equation will look like this. So AX is equal to B. Now 11 minus 2, here is 18, here is 48, here is minus 3. Sorry, I V1 V2 48 minus 3. So let's find the determinant of A matrix, so which is actually equal to 188. So if we are going to find V1, so V1 will equal to determinant of A, and we replace the first column of matrices A with the matrices B, according to Cramer rule. So V1 will actually equal to, if we find the determinant of this this term, so V1 is actually equal to 4.5 volt. Now so for V2, so we will put that V1 is actually equal to 4.5 volt. So for V2 we will put the determinant of A matrices, which is equal to 188, and the determinant of this matrices. So for V2 we replace column 2 with the matrix B. So 48 divided by 48 and minus 3. So V2 will equal to 1.10 ampere volt. 1.10 volt. So we found that V2 is actually equal to 1.10 volt. Now if we erase all these things, and if we look to the circuit, here in this circuit they want to find this voltage. So here we found that V2 is actually equal to this one. So V2 is actually equal to this resistance, this voltage. So Voltage across 3 ohm resistance is actually equal to 1.10 volt. So we found V1, V2, and if we are going to find that voltage across 2 ohm resistance, which is equal to V1, which is equal to 4.5 volt. So this is the end of the lecture. Thank you for watching.